First of all, we will discuss what is a wavefront. A wavefront is defined as a surface of constant phase. For example, when we throw a stone in a compound, what happens after a few seconds? You know that ripples of water can be seen, and if you take a photograph of this one, you may see that you can see some circles, concentric circles around a point, around the point of disturbance. So this circle can be assumed as it is having a constant displacement, it is having a constant phase while it oscillating, and this locus of all the points that has constant phase is known as a wavefront. So this can be considered as a circular wavefront. When we consider in a three-dimensional way, you can see that when we consider such a situation, we will get an idea of the point source that is emitting waves uniformly in all directions. Then the locus of point which have the same amplitude and vibrate in the same phase are spheres. Then this sphere is known as the spherical waves. Similarly, if we consider a distant point where the surface of this spherical wave can be imagined as a plane wave. So this is an example of a plane wavefront. So we can say that both spheres and spherical wavefronts and plane wavefronts can be considered in this manner. Here we discuss what is Huygens principle. Huygens principle says that each point we have to, first of all, let us suppose at t is equal to 0, we have a wavefront originating from a point. At a later time t, we have to create a wavefront of this wave itself. So the process says that, for example, if we take f1 f2 as the wavefront at a time t is equal to 0, then according to Huygens principle, each point of the wavefront is the source of a secondary disturbance, and the wavelets part of the wave emanating from these points spread out in all directions with the speed of the wave. Then Huygens says that these wavelets emanating from the wavefront are usually referred to as secondary wavelets, and if we draw a common tangent to all these spheres, we obtain the new position of a wavefront at a later time. So in order to create another wavefront, we need to draw what we have to draw at a time t. We have to draw circles because it starts from the point at a time t, it is spread in all the directions, so we can draw circles around the point. So when we draw another tangent to all these spheres, common spheres, so we can say that that is another circle of radius vt from the extra vt from the origin. So we can say that if the distance is radius r, means we can say that r plus vt is the new circle. So if you draw another circle, this circle will be the new wavefront. So this is the phenomenon. There is a drawback in this phenomenon. What is that drawback? Means here we can consider vt is the radius of the circle we can draw. So if we draw a circle in forward direction, we can draw a circle in the backward direction also. So that means a wavefront should pass to the forward direction and also should go to the reverse direction. So what happens means there is a wave to the to backward direction, that is not possible. So what is Huygens explanation is, Huygens says that if it is in the forward direction, we can say that amplitude is maximum. If in the backward direction, amplitude is 0. So he assumes that there is no waves forward moving for backward. So that's an assumption. He called it as an ad hoc assumption. In ad hoc assumption, what he says that it is not there is no backward propagation of wave. Okay, so this is called a Huygens principle.